right. Welcome, welcome. All right, let's play the slideshow. So today's our community call. We're going to go over, by the way, I'm Chris Katoya, Executive Director of cadCAD Foundation, also Product Manager at Block.Science Labs. Great to have you all here today. Today we're going to discuss spaces as they are defined in Generalized Dynamical Systems, which is the theory behind cadCAD in the first place, and then looking at how they've been implemented in working code and the new reference implementation in Python and in Rust, and just giving a general overview of the three framework initiatives we have going in Python, Julia, and Rust. So we'll have quick updates from the Infra admin working groups, course groups, and then go into the spaces implementation. So for the Different Education Working Group, we have two major initiatives that are being pushed at the moment, the cadCAD Wiki and documentation for cadCAD and how generalized dynamical systems fit into cadCAD and how those concepts are carried across the different implementations of cadCAD upcoming. Brock, who has been a very active member in our Discord, is heading up this initiative. We're really excited by it because it's going to help crystallize the specification requirements for these implementations, as well as just like increase the legibility of how cadCAD works for our community. And then the second initiative is the Bounties Development Program. Covered this one on the last call. Where we are, and this is the group I've been part of that's working with opensourcesoftwaregrants.com, where they're launching with collaboration with NumPy and Token Engineering Commons for their bounty program. That's still moving forward. We've been working on the requirements for what the cadCAD launch of this would look like, and that's all progressing there. Any questions before moving on? Cool. All right, so Core Tech Working Group. As far as state of progress and reference, we've made a lot of progress since last time. So blocks and points were in progress last time. We believe those are completed, as well as the DAG of blocks. So we're working on trajectories, and when that is done, models will just run in reference. So we're getting increasingly close to being able to sort of say like, hey, it's released in beta. Please test it out. Shake out some bugs, all that fun stuff. But we're getting really close. It's very, very exciting. Cool. Any questions before? Spaces, all the different implementations, was we wanted to show kind of comparisons between the different implementations to give sort of like a more meta sense of like how spaces work and a little bit more insight into a bit of like what GDS is and moving away from, I guess, the language specificity, whether it's in Python or Julia. We see this as being really helpful for starting the process of bridging communication and education gaps by having this sort of like comparative analysis, if you're using that really to drive the documentation work, which we'll be doing a lot more of the same thing in a lot more depth. And we see this as really important for us because it enables us to start continuing to onboard technical community members that can contribute to the projects, get feedback from them in terms of the framework designs. The whole sort of initiative of cadCAD reference in the first place came out of kind of living with the current live version of cadCAD 0.428 That's the current version of it right now. And realizing, okay, now that we've been using this thing, we've had enough people using it, getting feedback from it, sort of seeing the sticking points and the friction points for adoption there. Uh, that kicked off cadCAD reference work. And now we're at the point of cadCAD reference where we want to have some sanity checks and open up the group a little bit larger than the immediate community that's been working in cadCAD for the last 3 years for feedback and as a sanity check. And last but not least, start being able to put names and faces together on these efforts. So if people are interested, they know who to reach out to for the members that are driving these initiatives. Cool. Any thoughts or questions before diving right in? Lovely. All right. So just as a quick review, cadCAD reference is the Python implementation. We're really focusing on the expression of models, really making it friendly for newcomers, people starting their modeling journey. For Julia, we want a framework that's more focused on performance. Rust will be in the same vein as well. So less on sort of like the niceties of starting your modeling journey. It's more for people that really have a sense of they know exactly what they want to do, and they want to take a model that they've already expressed, perhaps in reference, and make it more sort of production ready. And with Julia, what's particularly interesting is Julia itself as a framework, rather language, is been developed by a dedicated community for scientific modeling support. So there's a lot of support in that ecosystem already for a lot of applications that we already know people interested in cadCAD want to use. So that was part of the choice for Julia. And then on Rust, we have a number of people that are systems and embedded programmers they like Rust. Rust has a lot of support, and it can run on a variety of systems, and you get WebAssembly from that as well. So you can sort of run things in browser. So that's sort of the three-pronged strategy, and now we'll get into it. So for the status of Generalized Dynamical Systems, the math spec team, as we call them, the formal paper has been published. The links below, and we'll share these links out in the follow-up tweet thread, are where you can find the white paper itself with the formalisms, and then the blog posts that Jeff, who is on this call, and a few others helped put together to really explicate generalized dynamical systems. The two key members of that are Zargam and Dr. Jamshid Shorish, as well as getting a lot of support from David Sisson for helping sort of drive the formalisms and the whole host of the Block.Science gang. On the reference side, we have end-to-end simulation testing at the moment. So trajectories is finalized, done, we're testing it. We're building up the unit testing and getting function level documentation. This will help sort of feed the larger documentation initiative as well. And then what they're working on next is domain-specific language for building up the pipelines of blocks, just making it nice to like wire blocks in your model. Key members of that are Emmanuel Lima. He's been driving all the core tech initiatives at the moment. Zargam as well, and Wolf, who's been doing testing support on that. And this is a really great example of why we started up the other initiatives in Rust and Python. Will was someone that was interested in seeing a Rust implementation, and so sort of kicking off those other projects was a really good way of kind of onboarding people onto sanity checking the reference implementation as well. He's got a project called the Plurigrid and is building cadCAD.jl so that his other projects can use cadCAD. And so Spaces is underway. It's awaiting review. And they're looking to sort of set up their own internal processes and get that going. Rust, we have Will, as I mentioned before. Brock is also involved on that. And Ben Tan, cadCAD Labs, he's also known by Ben Schultz, longtime collaborator with cadCAD. He also made the RAD-CAD fork in Rust already. So this will be, this initiative will be a much more updated version, more in line with the design changes we have in reference. So it's great to have them all working on this with us. We have Spaces in Rust being tested at the moment, and they're working on blocks next, and getting blocks underway sort of helps define if the current approach to Spaces is the right one. And so what's linked is the actual branch where they are working on Spaces dimensions. Any questions before we continue? Cool. All right. So what is a space? Space is pointed to a collection of dimensions, and it's the fundamental sort of like primitive structure in GDS, like all the other structures in terms of the models and what's described in Generalized Dynamical Systems, like require spaces. There's some fun math there. And so what we have is spaces are a collection of dimensions, as mentioned before, and each dimension is a pair name. It's a string, and it's either a regular type or another space. So you can get nested spaces. And then in terms of the functions that they have to be able to do, addition, multiplication, exponents, names, dimensions, renaming dimensions, is it empty, being able to unroll the schema and figuring out equivalency. Cool. So an example of how spaces look in cadCAD reference. This is one where we have a savanna. The space is a savanna. It's got a zebra population. It's got a lion population. So if you've seen sort of predator-prey models, it's kind of the thing you're instantiating for that. Cool. And you can define multiple spaces within your model. So there's another savanna with the gazelles and cheetahs. And you can do additions of this, right? So you can have a new savanna where it's the savanna with zebras and lions, and ones with gazelles and cheetahs, and create complex spaces by doing operations on top of other spaces you've defined.
And sorry, if you don't mind me jumping in, I'm just reading that. I guess it's the second to last comment that says instead of redeclaring a space from scratch, you can reuse them. In that sense, what's the difference, or maybe the better way to say is what's the relationship between spaces and classes? Because it looks like you could and I'm only going off of what I see here. It looks like you would also reuse the class as well. So I'm just trying to get the differentiation between the two.
Good question. Unfortunately, I'm not one of the technical contributors on this, so I'm not the right person to ask. But Emmanuel and Ben Schultz, and Zargum, Brock, Barton, they're all in the Discord. If you're interested, happy to follow up there. But I think the key thing is that you have space, and if you're wanting to sort of like, if you're renaming the classes, you're kind of getting rid of space. So the idea is like you want to keep some permanence about the space for whatever reason in your model. So yeah.
Yeah.
Okay, cool.
It's about like modularity and flexibility.
Yeah.
So if you knew you wanted to have a space that had all four animals in it, you could just take one class of, that's it. If you want to know, okay, I'm going to have these composable parts that I want to reuse again in other models, and for something much more complex, that's why you
Yeah.
The coding part here, like they're all classes, like there's classes, and by using the fixture space, that gets you some of the things that I described before about how, so the operations and how spaces and there's some attributes that you get.
Yeah.
Cool. Okay. Thank you.
Cool. We don't have an example in Julia, so I'll just move Rust example. So this is from the current unit test in the testing branch for spaces in Rust. As we see here, we're defining two separate spaces. It can be represented as a double recursion with sets of pairs. On the left, we have two spaces, and then on the right, we're seeing sort of that tuple construction, just more focused in. And so this is sort of like prospectively what spaces will look like in Rust, subject to change as they sort of move on to the additional elements in terms of points and blocks where additional affordances might have to be made. But that's the current state of Rust. That actually wraps up, that concludes the updates so far. Let me just stop streaming. Cool. Before we wrap up, it looks like, Thomas, were you the one that asked the question earlier? Okay, cool. Excellent. Yeah. So yeah, I'm curious what brought you to the call today. Your interest in cadCAD. Maybe we can help route you to the right working groups or projects.
Yeah, I mean, I would love that, honestly. So I'm actually an investor in Web3. I work at Consensus Mesh,
Cool.
which is, yeah, okay, if you're familiar. And so working with lots of token projects, going deeper and deeper into that space myself. I'm also not technical, so I had to, of course, take your guys' answers and translate it for myself a little bit there. But I'm getting deeper into the weeds on this, and so I wanted to understand cadCAD modeling overall, and I've been kind of getting more and more involved just because I think it from my perspective, and I'm again not super in the weeds on this, but it seems the leading in terms of complex models and getting really sophisticated from a token engineering standpoint. Seems like it's the leading solution, and so yeah, if there is anybody to connect with on like that front, or I'm just basically trying to learn as much as possible and get in the weeds. And I know I'm kind of loosely at the start of a journey where we might consider bringing somebody on board to do cadCAD engineering full time for portfolio companies or things like that. So yeah, still early days, but very interested.
Yeah. The other hat I wear when I'm not doing cadCAD, I work product at Block.Science labs, and we can help with that too. There's also Block.Science. They do like a lot more on the sort of like research and innovation side.
Yep.
So like, yeah, I can help direct you on that front. In terms of, I guess, like the key differentiator for cadCAD, it's that you're able to kind of combine an agent behavior model and a systems dynamics model in one object. And the reason why we're focusing on spaces on this call is because really what's happening with cadCAD is you're mutating the state spaces over time, and then observing how slight changes in agent behavior or system behavior sort of creates feedback loops and further mutates the system state. So it's the sort of thing that you can't really get with like other people using in token engineering, and those other tools are great, but it becomes actually kind of hard to model the dynamics that kind of define token economics.
Right.
Yeah.
I mean, I don't want to bogart the whole convo here, but I did have a question. I know I was talking to somebody who's built a few cadCAD models, and he was saying, and again, he'd only done like one or two, but he was saying from his impression that it felt like because the assumptions were so broad, and this has nothing to do with like the shortcomings of cadCAD or anything. It's just there are so many assumptions if you're designing an entire token network, that it's difficult to actually base those on any sort of reality. And that his view is cadCAD becomes incredibly more useful once you're able to connect it to real data. And I saw somewhere on I think it was one of the past community calls that that's something that's kind of in process, or you guys are thinking through in terms of how do we, hook it up to XYZ analytics from either on-chain or off-chain data sets. I guess could you just like connect some of those dots for me? Because I'm
absolutely.
Yeah.
So yeah, it's the idea of a digital twin. So the workflow looks like, all right, you're thinking about a design before launching. You want to model it, right? Because you got to build your intuition, right? Kind of the first time, particularly in Web3 projects, because it's really hard to update. So you go through a design, modeling, simulation phase, and there's sort of feedback loops there. And then you launch your token, very likely, and then you're transforming it into what we call a digital twin with exactly those live data feeds. Now, Barlin, are there any examples of projects you've worked with at the moment that have the digital twin close to or in place?
Yeah, there's a couple.
Yeah.
There's like 3 that we have.
Yeah. So there's 3 clients of Block.Science that have those digital twins live.
Yeah, that's great. So, and is that, I guess, in terms of like technology maturity, is that something that is relatively easily replicable, or is it, Block.Science did a ton of work to create those digital twins, and you effectively have to redo all of that work for the next client as well?
It's definitely closer to the second.
Yeah.
Just
Yeah.
You've got not only like building. I mean, there's the design and building of the model, but then like even if the design parts stay done, you already know what your model is. There's the building of the model, then you have the building of the data feed itself. You have essentially the whether it's a backtesting model, some sort of comparison model that's your essentially something that unifies the 2 models, the data model and your simulation model together. So
Yep. Okay.
Yeah.
That makes sense.
Yeah. And so sort of like the child company Block.Science Labs is a platform for basically handling all the DevOps out of data science. So it is on our roadmap to support those digital like hosting digital twins and giving solutions for the data feeds in. So it sounds like, Thomas, like there's plenty more we can follow up on in terms of the particular needs there, and happy to do so.
Yeah, same. Would love to connect offline or whatever. And
I'm happy to take it to DM. Cool. On that note, before we officially adjourn here, any other thoughts, comments, questions before we wrap up?
I just wanted to build on that conversation as well, that I think a lot of these models need to be contextually designed for the specific circumstance that they're in, but I'm also optimistic for sort of the replicable patterns or the primitives, and I know those that can also be quite complex on its own, but I'm really excited about some of these sort of replicable pieces that, as these sort of open source models become more prevalent,
Yeah.
that we can kind of create this modular library. And I think I'm really excited about Block.Science as sort of a modeling on the cloud, and a repository for these types of models, that in the future, as as these primitives get sort of fleshed out, the primitives in an electrical circuit are resistors, capacitors, inductors. When we talk about sort of these governance circuits, the design space opens up quite a bit more. But I'm optimistic for the day that there are these sort of maybe like case study or like context appropriate deployments that can be reused and reparameterized without having to start designs from scratch.
Yeah.
So I'm hopeful for that day, because I think it'll make a lot of this much easier to scale up this type of design without having to start every model from scratch.
Exactly. Cool. Thank you. Lovely. Well, I think that's all we've got for today's call. So thank you so much for coming, and see you all again soon.
Thanks, y'all.
Yeah, thanks so much. Loving these new emojis.
That's
Catch
cool.
you guys later.